So you should know what the chain rule is in differentiation, or if you have like f of g of x and take the derivative, it's going to be f prime of g of x, treating g of x like a variable, times g prime of x. And we can use the same logic in reverse for integration, and it might be a little harder, but still pretty simple. And this is basically like the very basics of integration by substitution, if you know what that is. But if you have an integral in the form where you have f prime of g of x, or a composite function, and the derivative of the secondary function, so like here we have f prime of g of x and the derivative of g of x, like multiplied by each other, and you can recognize that's the product you get, or the result you get after doing chain rule. So that means the answer is going to be f of g of x. And you just have to recognize when you have something like this, where you have your g of x and you have a derivative, when you have a function in your integral and something that's kind of close or exactly like the derivative of that function. So here's the example I have, the integral of x squared plus 1 over x cubed plus 3x dx. And you can notice that we don't really need to find our f prime of x or our f of x yet, but we can see that you always need to see that if you have a g of x and a g prime of x, and here we have a g of x, and notice that this x squared plus 1 is pretty close to the derivative of this, and we need to compensate by adding a 3 at the beginning, and then we have our derivative. And you can actually do that just by adding a constant and then adding another constant at the beginning of the integral to make up for it. And now let's rewrite this into a better format, more like this format. So don't forget the 1/3 at the beginning, and let's write our g prime of x, 3x squared plus 3, and let's write our f prime of g of x, 1 over x cubed plus 3x dx. You can see that our f prime of x is 1 over x, our g of x is x cubed plus 3x, and our g prime of x is 3x squared plus 3. And now we need to integrate this. As we said before, this turns into f of g of x, and it's going to do the same thing here. We need to find the integral of our f prime of x. So the integral of 1 over x is ln absolute value of x, and the derivative of ln x is 1 over x, so you should be able to know that. And remember to keep the 1/3 in front, and it's just simply ln of x cubed plus 3x plus c. And that's your answer. And use the same logic with keeping your g of x in your solution, your answer, similar in chain rule, where you just treat the g of x like its own variable or its own x, and you just keep it unchanged. So yeah, that's our final answer. And now I'll do another example. So for this one, you can see that x is close to the derivative of 5x squared minus 2. The derivative of this is 10x, which means that we're going to have to add the constant 10 in front of this x and just compensate by adding 1/10 in the beginning of the integral. So let's write this more clearly. 1/10 times the integral of 10x times 5x squared minus 2 to the power of 6 dx. And clearly our f prime of x is going to be x to the 6th. And to calculate the integral of that, you should already know the power rule, or if you don't, then just think about it in reverse. But anyways, it's going to be x to the 7th over 7. And we can replace the x with our g of x. So this is going to be equal to 1/10 times 5x squared minus 2 to the power of 7th over 7, or 5x squared minus 2 to the 7th over 70 plus c. And that's our final answer. And now let's do a practice problem. If you think you know how to do this one, pause the video and do it. This one has to find the integral of 5x squared times sine of 2x cubed dx. And you should notice that this is going to be our g of x, this is going to be our g prime of x, And so the derivative of 2x cubed is 6x squared. And so we're going to have to multiply this to get 6. So times 6 divided by 5, or times 6 over 5, and add 5 over 6 at the beginning to compensate. So basically, let's rewrite this cleaner. So 5/6 times the integral of 6x squared sine of 2x cubed dx. And so this is going to be our f prime of g of x, this is going to be our g prime of x, and this is going to be our g of x. And the integral of sine of x is negative cosine of x. And if you didn't know that, just think about it in reverse. What would I have to take the derivative of to get sine of x? Is cosine of x, but negative. So this is equal to 5 over 6 times negative cosine of x. But instead of x, we have our g of x, which is 2x cubed plus c. And negative 5 over 6 times cosine 2x cubed plus c is our final answer. So everything that I explained in this video and all the problems that I went through should teach you everything you need to know about using reverse chain rule and integrating functions. And it's okay if you don't really understand how to do this, because all of these problems could just be solved using U substitution. And if you don't know what that is, I'd suggest go learning about it. But yeah, even though this is an easy integration technique, it's not really necessary to know, but it's very helpful sometimes. So if you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.